Number 7. Would an apple held 1 meter above the ground on Earth and on the moon have different, or potentially the same, obviously, gravitational potential energy values? Gavin, what do you think? Apple on Earth, apple on the moon. Same or different?
It would have the same, wouldn't it?
Tell me why. Tell me why you think so.
Because it's still going to go down, so it's going to still have the same potential as the second on Earth.
Good. So it's going to go the same height. You're exactly right. It's going to be the same motion. It's going to speed up as it falls. But let me ask this question. Is it going to have the same result at the end? So, Connor, what do you think? When the apple on the Earth and the apple on the moon get to the ground, will they be the same when they get to the ground on both places? So think about, so potential energy is the ability to do stuff. The stuff is falling. Will they have the same speed at the bottom?
Okay, so you're asking if they're falling at the same rate still?
Yes. Are they still going to fall at the same rate?
Well, are we counting for atmosphere or not?
No, let's ignore air resistance.
Okay. Then they probably, I think they still could.
So they will fall, they'll both accelerate, but here's the key. This thing here. They're going to fall differently. And the reason they're going to fall differently is because on the moon, good job. Oh man. On the moon, G equals, I think it's like 1.62. Don't quote me on that. I'm not exactly sure that's what it is, but I think it's pretty close. On the Earth, G equals 9.8, obviously. So even though it's the same mass and the same height, the result will not be the same because an object dropped on the moon cannot go as fast as an object dropped on the Earth unless you drop it from a much larger height. So energy, potential energy is the stored energy to do stuff. It's energy that's held in readiness to make things happen. An object on the Earth can actually have more energy than an object on the moon. And just to show you here, notice what happens to my potential if I change gravity. It has more stored energy to do more stuff if I increase what gravity is. Now, there is a bit of a balance factor here because you'll notice I won't be able to go as high now. So it was all the way up to 5. Now it's only going a little bit over to 4. But you'll notice all my values are just larger overall. My speed's higher, my kinetics are high, all those things are higher. So, yes, it is possible to have... so would they have different gravitational potential energies? Yes, they're going to be different gravitational potential energies because they have different stored energies. Good, excellent job. All right, number 8 is tricky. How can you have two different objects with one object with two different potential energies? Here's how. I have a ball, and I say that the ball is 2 meters above the ground. And let's say 1 meter above the ground. But my son, who always likes to be contrary, is like, no, Daddy. The ball is not 1 meter above the ground. The ball is 0.3 meters above the table. Who's right? Me or him? Yeah, good job. Oh, yeah, you guys are catching on. I like it. We're both right. We're both right. Potential energy is the stored energy to do things. If I'm dropping the ball over the ground, it's going to be able to do more stuff. It's going to be able to turn into more kinetic than if I drop it on the table. So it just depends on what I do. If I drop it over the floor, it has more energy. If I drop it over the table, it has less. Did I do anything to it? No. I just changed what it can do. So how can you have two different objects, or how can you have one object with two different energies, two different heights? In one case, I made it the height above the ground. This is where I said 0 was. And one of them, I made it the table. This is where I said 0 was. Remember from the front, we said height above what? It's the height above 0. If I make the table 0, then the height is 0.3. If I make the ground 0, then the height is 1. It didn't change anything about the object, but it does give two different potentials, which explains why it will not go as fast if I drop it on the table than if I drop it on the floor. Questions on 8? 8 is weird. Okay, number 9. Nathaniel, tell me what number 9 is. What's kinetic energy? Yes, energy in motion. Remember, energy is an ability to do work. Its energy is what allows an object to do stuff. If an object is traveling fast, can it do work on objects? Yes, if you get hit by a car, things happen to you. Okay? Objects that have motion can do work on stuff. And the equation for this is Ke equals 1/2 mv squared. All right, number 10. What's the relationship between work and kinetic energy? It's this. Work equals a change in kinetic energy. Remember, we said there's two types of work. There's work done against a force, which is what we've talked about so far. And then there's work done to change speed. This is the change speed kind. Okay, why does a car traveling twice as fast as another take 4 times further to stop? So if I have a car that's driving down the road at 30 miles an hour, we'll do meters per second. This is going to be ridiculous because 30 meters per second is about 60 miles an hour. Okay? Let's just say it takes 10 meters to stop. If I have a car that's going twice as fast, 60 meters per second, so 120 miles an hour, it's not going to take 10 meters to stop. It's going to take 40. Why? Why would doubling that make 4 times of a difference? Here's why. Work equals a change in kinetic energy. Now, the way we do change, as always, is final minus initial. So, if I stop, my final kinetic energy is 0. So, work is force times the distance. If I stop, my final kinetic energy is 0, and my initial will be 1/2 mv initial squared. So, mass is constant, that doesn't change. The force is the force of the brakes, that doesn't change. Your brakes can only apply so much force. So here's what changes, the distance and the velocity. Here is why doubling the velocity quadruples the distance, because it's velocity squared. It's velocity squared. It's not 2, it's 2 squared, which is 4. 4 times more energy. Not double the energy, 4 times more energy. 4 times more energy means we need 4 times more work. That's why it's 4 times more distance. Work is force over a distance. If you can't change the force, the distance is what changes. This is why they don't tell you in driver's ed, they don't say follow 10 feet away from the car in front of you. They say follow 1 second away from the car in front of you. Because if you're going faster, you have to give yourself more distance. If you're doing time, you're giving yourself more distance. Right? 1 second away from a car in front of you is a lot further if you're going faster. Last one. With what measurements are potential and kinetic energy related? If you see the word velocity, you should think kinetic energy. And if you see the word height, you should think potential energy. Just like remember in the momentum unit, if I gave you velocity, I meant for you to find the momentum. In this unit, if I give you the velocity, I want you to find kinetic energy. If I give you the height, I want you to find potential energy. But we'll talk about the math stuff here in just a little bit.